Hi everyone, my name is Harizo. I work as a partner engineer at Mistral AI, and today I'm going to talk to you about tailor-made data quality test and evaluation with Mistral Large on Snowflake Cortex. So a brief word on Mistral AI before we start. So very briefly, Mistral AI is a French company which is a little more than 1 year old. And we are basically building state-of-the-art large language models, both in terms of performance and efficiency. We are also proud to be partners with Snowflake since March 2024, and our latest flagship model, Mistral Large V2, is as of today available on Snowflake Cortex. So if you're watching this presentation, it means that you're interested both in, let's say, text-oriented data processing and LLMs. And there is a lot to say about LLMs and data quality, but mostly it's about two things. The first thing is basically to take a step back and redefining what it means to assess data quality when it comes to unstructured and potentially large text data. Because in this context, you will have the definition of bad data, which will in a way differ from what you may already be used to in traditional data engineering. You will look at metrics that are well defined, while with unstructured text data, you will have to redefine things according to your own use case, which means that you're also going to need to build your own metrics. You also require, well, text data use cases also require to think, let's say, outside of the box and handle a much higher cardinality in terms of possibilities because it is easy to understand how good and how bad a model is at classifying sentiment, for example, which basically translates into a good old classification problem. In the case of LLM-oriented use cases, you will have things like summarization, which is completely open-ended and for which you will need to think a bit more and provide your own definition of, let's say, how good a summary is. There is also the part about tooling, where with the introduction of LLMs, you have to think more in terms of how you're gonna use natural language to interact with your data and with your application. And when you put that in the context of a tool like Snowflake, well, it also implies that you need to define ways to basically inject a prompt-driven logic into something that is data-driven in the form of tables and data frames. So in a way, different interfaces, but sharing the same goals because those data quality problems, they're still here. And there are many of them. So, like for this presentation, I wanted to try and provide like 3 examples on which the demo that will come later will focus on. So, the first one is about off-topic data. So, this is our quality issue. Imagine that you have to process a stream of data and you're only interested in specific topics for which this data relates to and you want to filter out the rest. So this can be seen as a regular classification problem, but in practice, if you want to get more flexibility, what you want to do is provide, let's say, a more fine-grained definition of what those topics are, and also find a way to ask your classifier to provide explanations on why a given piece of text was classified into a given topic. The second example is about unsanitized data. So more often than not, when you have to process text data, it can happen that this data may expose sensitive elements such as PIIs. Technically, when it comes to customer service, emails, this kind of thing can happen. And to add to the complexity, you can also need to deal with that in different languages. And in that scenario, what you may want to do is not just to flag those sensitive elements, but also to streamline their reduction in your text data. We'll see how we can do that with LLMs. And the last example is a bit different. It's not about the quality of the raw input data stream. It's more about the quality of a first step that has been applied to your raw data, which is summarization. So imagine that you receive a stream of data. You have to first summarize them, well, summarize each of the data items before basically moving them downstream to any arbitrary processing steps. The first thing that you may want to do after summarization is to make sure that the summary is good, because if it's not, it can impact the whole pipeline, let's say. So you may want to add an evaluation step where you're basically going to grade the quality of the summary. So this is data quality, but not on the raw data, but on the output of the first step. Implementing those solutions will effectively require a tool that can do many things. It needs to handle natural language instructions, possibly in multiple different languages in an agnostic fashion. It also needs to be highly customizable, meaning that for any topic that you may want to define, for any PII that you may want to list, you want the user to be able to specify what they are as precisely as the user wants. And third, you, of course, want to handle that on potentially complex text. So you may want your tool to be able to handle advanced reasoning for potentially complex tasks that go beyond simple text processing. And fortunately, at Mistral, we do have that. And this comes in the form of our Mistral Large 2 model, which is also available on the Snowflake Cortex platform. A very quick word about Mistral Large 2. So this is our current flagship model as of October 2024. It can basically handle very easily highly complex multilingual tasks. It does so while retaining optimal efficiency in terms of numbers of parameters. And it also excels at things such as instruction following, function calling, and other, let's say, key aspects of LLMs that are expected by the users. So now, if we want to apply that to a context where you, as a user, work on Snowflake and especially Snowflake Cortex, then there are basically two programmatic ways to interact with Mistral models. So in this case, Mistral Large 2. They both rely on basically what is called the complete function. And this is going to be like the same function that will be executed either in pure SQL or in Python via the proper SDKs. And the structure is always the same. You provide the name of the model and you provide a prompt. And what you will get as an answer is the output of the Mistral Large 2 model. How do you insert that logic that is prompt-based into a workflow that is table or data frame-based? So this is what we will see in practice later on, but just to give you an overview of how things look like, it is basically going to be a multiple step process where you have your text, the text that you want to process. You're going to define a UDF, so a user-defined function that for each element of the text column is going to build the appropriate prompt to send to the LLM. And then we're going to rely on this complete function that we'll call Mistral Large under the hood to perform the operation at hand and provide the output in a new column. So our main tools for that will be the complete function and the Snowpark Python API. We will have one additional step when it comes to the evaluations part, where we will need to actually introduce two different models and add a new intermediary column, but we will get to that later on during the demo. Let's now switch to the demo. So for the sake of this demo, we're going to work on two different data sets. The first one is going to be used for the topic relevance, quality processing, and also the summarization evaluation processing. And this is an open data set that contains basically news from the BBC tagged by ID and where you have basically here a text column and a labeled category. So our job will be to, in the first step, to in fact try to reproduce this category column using advanced classification techniques. And the second dataset is a synthetic dataset that basically contains a bunch of records that can be either emails or messages, but all of them are, let's say, formatted in different fashions, and they do contain a variety of PIIs, and we'll see how to basically identify and redact them later on in the demo. So let's get started. We're going to run everything from this Jupyter notebook over here, and we are going to start with the topic relevance analysis. So as we saw earlier, here we are dealing with a handful of articles, and what we want to do is basically to classify them following a given list of topics. So if we were to reproduce what led to this category column here, one way of doing it would be to rely on a built-in function of Snowflake Cortex that is called classify text. Let's take a look at a sample of this data. So here I'm going to fetch the 800th records of the table. And this is the text. And now if I apply this classify text function that comes with the Cortex API, what I'm going to get is a classification in entertainment. What happened is that we passed a list of labels that could potentially apply to our article. And then this classified text relied on some LLM, some internal LLM that actually did the classification task. But what if we wanted to go beyond that? What if we wanted to provide not just labels, but also descriptions for each of the labels so that you as a user are sure of the quality of the classification? And this can apply not just to this use case, but to any other business use case where you have your own business-driven labels and you want to make sure that they are properly defined with as much detail as possible. So to do that, we are going to start with this function that is going to actually take a more detailed description for each of the label, and it will also come with something extra, which is this other category here that we will use to basically classify anything that do not belong regarding to the LLM to any of the previous categories on top here. So let's see what this does. So in this cell, we're defining two things. We're defining this function, and we are also declaring the UDF that Snowflake is going to use to basically wrap this function into something that can be easily applied inside a table or a data frame. So let's declare this table, this UDF, sorry. And if we are to basically check what is happening, we can execute this cell. So the first part of the output here is basically the rendered prompt, where you see exactly what you instruct to the model. So the mission is to classify these texts. This is like the list of topics that we saw earlier. And you define the format that you expect, and then you provide the text. And the idea is basically with the UDF to apply that to every record of all or part of the table that we saw at the beginning. And as you can see here, things are looking interesting because it properly classified that as entertainment. But beyond that, it actually did two things. First of all, it basically respected the desired output format that is like JSON-like here. But also it did provide details that justify the decision of the model, and that can come in very handy when it comes to any like business-driven decision when you have to classify things, or even at debugging steps. As a data engineer, you may want to know why a given piece of text was or was not classified into the categories that you want to retain. So the next step here is basically to rely on Snowpark data frames, and apply the logic that we saw earlier to apply for each record the prompt here. So we are going to build the prompt dynamically with respect to the record at hand. And then we are going to run this operation, so the complete operation. And we are, in fact, going to write the output of this classification, so this part here, not just as a plain string, but as a more structured object that is called a variant. So we can actually check what this is going to look like without writing the table. So here I did that on a limited number of rows for the sake of the demo, but this is basically what the content of the table will look like. And as you can see, you will not get only the topic that was classified, but also details on why this article was classified into that topic. So the last step here is to write the resulting table. So we're going to create that table and write the content of our data frame into that table. Once this is done, we can check into the list of our table that it was properly created. As you can see, there it is. And we do have our 5 records. Very good. But this is not the final step, because remember, what you want to do is basically apply filtering on, let's say, the topics of your choice. So imagine that now you're querying that table using this SQL query here. This is all nice and well, but now what you can do is, so this is like the classified output, but now anyone who queries that table can actually also get the details that we have here in addition. And here we have the details. And now what we can do is just apply our filtering logic just by adding a where statement like this. Where. And now if I want to only retain the business articles, I can do this. And there it is. I filtered out anything that do not belong to the business category. And I also provided explanations on why this was classified as a business related text. So remember that we also have this like other category. So to handle it, what we're going to do is actually get an additional piece of text, not part of the original table, but here this is about the announcement of the latest Nobel Prize in medicine. And since medicine is not like part of our initial categories, which are business, technology, over here, entertainment, politics, and sport, we want to make sure that our model does properly classify that as other. And this is a few lines. And here the output is, well, we did classify it as other. And now it says, why did it classify that as the other category? Because it does not fit into the existing ones. Next on is PII detection. So we're going to apply the same kind of reasoning. Remember, what we want to do now is to deal with this data over here. And what we want to do is basically to redact the PIIs, making sure that they do not appear in any downstream processing. So we're going to apply the same logical steps as before. We're going to build some kind of prompt template, and then we're going to apply that prompt template to a sample of our table and look at the output. So here, again, we as a user have full, let's say, we have the full flexibility of defining exactly what we want to define as PII. So here I wrote down email, name, phone number, address, company name, but in your use case, you will be able to define any other item here, maybe something more specific to your use case, maybe adding more details. And here I'm just telling the model to replace every match with this mask substring. And again, as a user, you will have full flexibility on maybe switching this replacement mode with something else. So let's declare that function. Let's test it on a very simple use case. So here I want to make sure that the name and the email address are properly redacted. So I'm creating the prompt from my prompt building function. I'm passing in the input text. And as you can see here, you have on the top what was passed to the model with the input, and the output contains the properly redacted version of our input data. So now, same as before, we're going to apply that not just to one string, but to many rows. So in this case, we're not going to take the whole table, of course, but the logic will be the same. We're going to define a UDF. We are also going to create a Snowpark data frame with our steps. So again, you create a column that is called prompt that contains the input of the LLM where the prompt building function has been applied. You're going to use the complete function to actually run the operation that you're looking for, in that case, the PII reduction operation. And then we are going to select basically a few elements and see whether or not the reduction operation has been properly done. So here I'm going to test that on one record of my data frame. So let's take a look. All right. So as you can see here, we have a fairly large text input that do contain a mailing address over here. We do have an entity here, so Camera McKnight, and a name here, Jenny Body. So let's take a look at the output. So this is the redacted output. And as you can see, we did effectively redact our names, email addresses, company names. As you can see here, we have like all of those things were redacted elements. And if you take some time to read through everything, you will see that in every thing that we labeled as PI was properly redacted in that record. So now the last step is same as before, to create a table that is actually going to contain the output of our PII reduction task, and we're going to apply that to the first 5 rows of our table so that it doesn't take too much time. And once this is done, we'll be able to check in the Snowflake UI that things have been done properly. So now if I refresh this, I should be able to see my new table over here. And if I go to data preview, I have my table with the raw text and the redacted text. So the last example is something that is called LLM-as-judge. It may sound complicated, but it's definitely not. Here, the idea is to say that if we just roll back very quickly to this slide here, we're going to have a first model. So this one is going to be an internal Snowflake model that actually maps to the summarize LLM function in Cortex, produce a summary from the BBC News article dataset that we had at the beginning. But then we're going to ask Mistral Large to actually grade that summary. We're going to give it the raw text, the summarized text, and a list of evaluation criteria that we are going to define as users to make sure that this summary does abide by the rules that we provide to basically assess what a good summary is. So back to the code. We're going to actually start with this summarize operation. So this is going to show you an example of how it works. This is the raw article. This is the summarized article. So our goal is to basically check that this summary here at the bottom is basically abiding by these evaluation criteria that we are going to define in the prompt building function. We're going to look for two things. Well, four, in fact. So conciseness and coherence, and accuracy and completeness. Again, here, emphasis on the flexibility of this process. The text that you fill in here is entirely your work, meaning that you will be able to very precisely define what exactly you're looking for in terms of quality when you're looking at summarization. So in that case, we retained like simple criteria. And same as before, we're going to declare that function. We are going to look at what it looks like. So in practice, you will have the instructions sent to the model, and then you will have the article and the summary. So this is the entire prompt that is going to be passed for one given, let's say, record to Mistral Large. And if we run the evaluation process, Mistral Large should be able to look at this and then apply grades. Here, we asked it to, for each criteria, to provide a grade between 0 to 5 and a few details that justify that grade. And in this example, we have like 3 out of 5 for conciseness and coherence. This is expected because here I specifically tasked the judge, so Mistral Large, to consider summaries that are 1-2 sentences long as a good length. So this is an example of like how custom you can be when it comes to defining the criteria on which you want to apply this LLM as a judge pattern. But other than that, it seems to do actually well. So same as before, we're going to expand that to not just one record, but to something that is more like a table or data frame. So creating the UDF exactly as before. Note that this time we're going to have two input types, so the text and the summary. We are going to create a table that will contain the article ID, the initial text, the summary, and the evaluations. So for the sake of simplicity, we're just going to store the evaluation output here as plain text. So let's create that table. And now let's run this evaluation process again on a limited number of rows for the sake of the demo, 5 here. And as before, what we're going to do is create a first column that contains the summary done by the summarize function here. Create a second column that is called prompt, which will actually contain the generated prompt with the instructions, the initial text, and the summary, and the evals, which will be the output of the evaluation process done by Mistral Large, taking this prompt as an input. I can see that this is done here, so let's make a final check to verify that our table was properly written. PII detection output is the previous one. But now if I go to BBC News SumEval and data preview, I can see that I have, like this, the text, the summary, and for each record, I do have grades and explanations. So to conclude, in this presentation, we took a glimpse at how you can combine a flagship model like Mistral Large and tooling provided by Snowflake in the form of data frame, tables, and the complete function to handle, let's say, complex data quality tasks such as topic classification and filtering, sanitizing PIIs, or assessing summarization, let's say, goodness of fit. We saw that flagship LLMs such as Mistral Large are powerful and versatile tools to handle those, and that combining this model with the existing framework within Snowflake that exposes tables and data frames can also be easy thanks to the provided SDKs and especially the UDF capabilities. So this opens a lot of possibilities when it comes to batch processing, which is something, well, standard in the world of data engineering. And last but not least, we saw that with this complete function and the ability to specify yourself a fully customized, crafted prompt, you have the ability to basically have tailor-made, let's say, functions that will allow you to handle anything that is specific to your use case, and that would go, let's say, beyond plain summarization or translation built-in functions and become something that you basically carve out yourself for your own business use case and to fulfill your very own needs. And Mistral models have been built to handle that level of customization. So that's it for the presentation. I hope you enjoyed it. Thanks for watching, thanks for attending, and don't hesitate if you want to get in touch.